So sine squared 25 plus sine squared 65. We're on page 152-ish. This is mine. I might have updated it. What is this on yours? Oh, good. Every other class is different. So I don't have an identity that says I can add those together and make it 90. That's not an identity that we have. We can't just make stuff up. So start thinking. Like we talked about a rat in a maze. He's sniffing around. Is there anything that resembles sine squared plus sine squared? Anyone? It's probably the most common identity on the planet in terms of trig identities. Okay, there is a sine squared theta plus a cosine squared theta. All right, so we do have that, but that is clearly not this, right? So the question is, if we have a sine squared theta plus a cosine squared theta identity, how could I change one of these to a cosine? Or is it possible? Can I change a sine to a cosine? So do you have an identity that changes sines into cosines? Let's try it. I'm sniffing around, right? So if sine of, she said, sine of theta is cosine of 90 minus theta. So sine of 65 would be cosine of 90 minus 65, which is what? Cosine of 25. So that becomes, based on this, a cosine of a 25, based on the cofunction identity. Don't forget the squared. Bring down the rest of this. And now what do I have? I have a Pythagorean identity. And sine squared plus cosine squared is always equal to 1. Well, then this is equal to 1. But that's me showing this proof. And that's a great test question. And I could do that with sine squareds and cosine squareds, tangents and cotangent squares. But sine and cosine squareds, more common. What if I change this to a minus? I'll tell you what. Yeah, what if I change it to a minus? Do you have any trig identity that's even close to sine squared minus sine squared? Okay, so you have a cosine squared theta minus a sine squared theta that's equal to a cosine of 2 theta. And if you know that, then is there any way to change this? Yeah, again, I can change a sine to a cosine by going sine of 25 is equal to the cosine of 90 minus that 25. So cosine of 65. So that would become a cosine of 65. Don't forget the squared. Right? Which is a cosine of 2 theta. So if that's the theta, then a cosine of twice that theta would be cosine of 130. These are the kinds of identities that you have to know on a test. And you have to be able to kind of hunt around for it. They're a little different. Y'all seeing that? And I'm not saying that's the only way you could do it, but it's certainly the most simple way you could do it. But you got to be a little creative, and most of the time, you don't have to be that creative because you've seen all this stuff before. Anybody have any other questions on any of these trig identities? How about this? What if I gave you this? Here, I'm going to change this. Call this 31A if you want to write it below or something right down there. 31A. What if I made that positive, that negative, and I don't know, 120 degrees? And who cares about that sign, really? So 1 plus cosine 120, 1 minus cosine 120. Do you even recognize that identity with the plus over the minus? Which one do you know? And the minus over the plus is a what? It's a tangent of theta over 2. Now there's a sine of theta over 2 that's 1 minus cosine over a 2. and there's a cosine that's a 1 plus a cosine over 2. But this is not a tangent because it's got the plus on the top and the minus on the bottom. Well, what do you think it is? To me, that just looks like I've flipped it. So if the tangent of the half angle is the minus over plus, what do you think that is? It's a cotangent identity. Now, we haven't talked about those, but if you needed one, you could just, if I need a cotangent half angle, flip one of the tangents. And it's very likely on one of your identities, you're going to see stuff like that, and you have to know your identities well enough to go, wait a minute, that is a reciprocal of a half angle tangent. That means this is a half angle cotangent. Half of that angle, which gives me cotangent of 60, which we know is root 3 over 3. And if you noticed on my keys, if you're wondering why, when I have this, sometimes my keys will have absolute value on them, and then I'll simplify. Anybody got an idea why that's the case? Like, tell me, why on an identity would this is true, but why if I gave you that, and without the plus or minus, like I did here, why would you have to put absolute value? The answer to that is, tangent of theta over 2 is not both of those. It's you pick it. Like, for instance, what if I said tangent of 60 over 2? That's what you would do to simplify this, right? Put 60s in. Well, tangent of 60 over 2 is the same thing as tangent of 30. And if I'm taking a tangent of an angle in the first quadrant, would it be positive or would it be negative? Positive, because it's in the first quadrant, right? And it's tangent. Everything's positive in the first. So you would say, oh, positive. And you choose, right? Well, what if I said, what's tangent of 300 over 2? Well, you come over here and plug a 300, right? But the problem is, this is going to give me a positive value because I'm square rooting a positive. I'm square rooting it. And I can't get a negative. I can't square root a negative. I have to only square it positive. So this ends up being positive here. And when I square root it, it's still positive. But isn't 300 over 2 the same thing as 150? And where is 150? Second quadrant. And what's tangent in the second quadrant? Negative. Y'all remember all this? So I choose to make it negative. Not because the 300 actually also would be negative because it's down there in the fourth, but it's the total angle, right? This is going to decide whether the cosine's positive or negative there. But the total angle right here, that's the second quadrant, and tangent in the second quadrant is negative, so I choose the negative. But it's a choose, right? So if I start you with this, I'm telling you right now that when I square root all of this, I can't square root a negative. So that means all of that's positive, right? So if that's positive and you square root it, what are you getting? A positive. So you have to make sure it's positive. Well, look at this. Cotangent of 120 over 2 ends up being cotangent of 60. It would have been positive, right? It would have been. But if I didn't know that, if I didn't know the angle, I'm not sure. Like if I didn't know the angle here and I said, what identity is that? And all I do is say theta over 2, isn't there a chance that like when the angle's 300, I get cotangent of 150, which would have been negative? But this can't be negative because I'm giving you the left side, I'm telling you it's positive. So you have to ensure that the identity stays positive. Are you seeing that? Now, I usually don't take off on a quiz for that. I usually give you a bonus point if you remember it. That's probably how I'll treat it this year also. But if I ever am going this way and I've already chosen for you that it's positive, then you have to ensure it stays positive with that. That makes sense? Like this. 1 plus cotangent theta over 2. What identity is that? That's half angle cotangent when the angle's pi. I'm sorry, half angle cosine. Now, what I would normally do is say, wait a minute, it's already chosen to be positive. I need that to be positive, or at least not negative. right? So I would normally do that, although it didn't really matter here because what's cosine straight up? 0. So it really wouldn't have mattered in this case. But had that been another angle that when I divided it by 2, put it in the second or third quadrant where cosine's negative, I can't have it negative. It said it was positive, so I have to make sure it stays positive. Anyway, guys, you got to make sure that you know these. I can bring you to water, but I can't make you drink. So you have to know all of these identities, and you've got to know them kind of backwards and forwards. And literally, when you're looking at all these, they should be recognizable to you. And if not, you really need to work on these kind of problems, make sure they're recognizable. Because we're taking a big leap today. Okay? So normally I put you in groups, but because that's really not allowed, you can't really put all your desks together and breathe all over each other. So we must keep each other safe. So I'm going to kind of just walk through some of these for you. And some of these you're going to see some problems you haven't seen. In fact, I'm going to start you. I'll tell you what, we'll start off with number 1. And then we get there, we'll get there. So on number 1, and this is from an old University of Alabama test back in the 80s, or the 90s. It says solve for x. So I've got an x on the left, I've got an x on the right. Normally when we solve for x, what do? Like generally, solving for x in an equation, you get everything over on one side, try to do something with it. If I move this over on this side, I get an inverse cosine minus an inverse tangent equals 0. I don't know where I'm going to go with that. That's going to be pretty tricky. So if I'm just kind of desperate, maybe if I can't get them both together and isolated, maybe I just get one of them isolated and see what happens. So is there anything you can do to get one of these x's by themselves? Take a random guess. Okay, so I'm going to not multiply, but I'm going to take the cosine of both sides. So if I took the cosine of the left, the cosine of the inverse cosine of x, and then the cosine of the inverse tangent of x, what happens here, do you think? Now it cancels. Now, I've told you be careful and don't just cancel them always, because sometimes this value is undefined. Sometimes the angle that it ends up being is going to be in the wrong spot. I said normally we're going to draw a picture, but look, even if we draw a picture here, remember this x is not an angle, it's a value. So I'm solving for the angle that would have a cosine value of x. So if I were to draw this angle right here, theta, if I were to draw that, I know that the cosine of it, the adjacent over the opposite, over the hypotenuse, the adjacent over the hypotenuse would be x. Well, now I'm asking you, what is the cosine of this angle? Well, I didn't even need to find that. The cosine of the angle is x over 1. So in problems like this, don't overthink it. If it's a variable and it's cosine inverse cosine, you can just cancel those. Now, what about this? You've done these actually in the last test. You're going to see this kind of stuff again. So what is this saying? Inverse tangent of x is going to give me a what? I'm asking you to find the inverse tangent of x, which is a what? X is a what? So when I inverse tangent, I get an angle. So this right here represents an angle, which I'll never find, but I need to find the cosine of that angle. So I'm going to say, all right, inverse tangent of that value. Now, inverse tangent we know is defined there and there, right? I don't know whether x is positive or negative, so I'm just going to draw a picture here. But it does tell me that the x, the tangent, is the value. Opposite over adjacent is x and 1. And my theta would be right here. And now I want the cosine of that angle. Well, I would need to know the hypotenuse, so I do a little Pythagorean theorem, and I get x squared plus 1. And the square root of x squared plus 1 is not x plus 1, so don't do that. So now the cosine of that would be the 1 over the square root of the x squared plus 1. Are you with me? Now you think you'd be really happy right here, except you look down here and you go, what the heck is that? Well, this is an equation. If this x had a number, I'd have an answer, right? Like if this said x equals 1 over square root of 4 squared plus 1, well, I'd have an answer. But what I have here is an equation with two x's in it. If I had started you right there and said solve, would you have just said, oh, there's x? Or would you have said, I can't define x in terms of another x, I gotta solve this. So what would you do right now with this equation? I mean, you really have to not assume the position here. What would you do if I handed you this equation and said solve? What's bothering you? Okay, and how do you get rid of a radical if it's an equation? You could, but you're still going to have a radical when you do that. Square both sides. I'm allowed to do that, right? Now, I might get some extra answers that I need to go back and check when I'm done. When I start squaring both sides, I get more answers. So I might have to check them, but let's try that. That'll get rid of the radical. It really makes it look a lot better instantly. All right, now I have this, looks a lot better. I'm going to get rid of these pictures right here. Now what do you do to solve? What would you do? Cross multiply because you don't like a fraction? When I multiply those two, I get what? X to the fourth plus x squared equals 1. Now what would you do? You're going to have to get a little creative. Again, if I gave you this and said solve, what would be what's your mentality? I was just teaching this to Algebra 2 people. You always do what? Set it equal to 0. So take that 1, subtract it from the other side. Then what do? Once it's equal to 0, factor it. Now, I can't factor that. But does it mean I can't solve it? What can we do when we can't factor quadratics? If it's in quadratic form. Quadratic form means like a constant, an x, and an x squared. But it also works with a constant, an x squared, and x to the fourth, or a constant x cubed, x to the sixth. What could I use to solve a quadratic that doesn't factor? Quadratic formula, except instead of solving for x, what would I be solving for? Okay, so let's try it. There's my a, there's my b, there's my c, -1 is my c, and I'm solving for like the x squared. So I'm going to say x squared equal, which also kind of makes it look similar to maybe that. X squared equals the square, -b, -1, plus or minus the square root of b squared, 1, minus 4 times a times c, all of that over 2a. Now what does that give me? Let's clean it up. -1 plus or minus the square root of 5. Oh, that's starting to look familiar. All over a2. And then now I've got it down to where x squared is, so what would x be? Square root both sides. So when I square root both sides, I get -1 plus or minus root 5 under the radical over a 2. Right? Now, is that my answer? It's pretty close. The only thing that I have that it doesn't have is that extra negative right there. Why do you think they tossed it? What's -1 minus root 5? It's negative. And when I divide it by 2, it's still negative. And when I square root it, it's now imaginary. And x is a ratio of two sides. Can I have a ratio or a value that's imaginary? So I toss out the negative. Now you may look at that and go, oh dear God, don't give us that one. And I don't know that I would, but the point is, did I just do anything that was above or beyond your pay grade, other than sniff around a little bit? Right? Now, would I give you something like that on a test where you've never seen something before and you're like, oh my gosh, what in the world would I do? I doubt it. But my point is, I might give you something like this, but it actually just solves a little nicer. Maybe there's a number in there where you got an inverse cosine, but you actually can find the value and call it a day. So I don't have to make it more of an algebra problem, but I can actually do something. What about number 2? By the way, I'm going to want you to know this. There's a proof to that I used to do, but it takes a lot of time, so I'm going to skip out on it. But I want you to memorize sine of 18. Root 5 minus 1 over 4. It's not that hard. So hypothetically, let's just say I know sine of 18. Can I simplify that? And a lot of times on a test, I would give you just this part. And say, can you simplify? Anybody got any ideas? Take a shot. You see any relationship between 54 and 18? Okay, can I randomly just walk around and multiply stuff by 3? All right, but along that line of thinking, there is a relationship there. 54 is 3 times the other angle. 3 times the other angle. So you're saying the sine of 54, I'm going to bring this down. Oh, okay, let's deal with the negative part. What can I do if it's sine of negative 54? Pull the negative out. So I'm going to pull that negative out all the way to the front. And I'm left with sine of 54. And you just said sine of 54 was the sine of 3 times an 18. What does that sound a lot like? The triple angle sine identity that is on your sheet to memorize, right? And by the way, if you don't know what the triple angle sine is, and I gotta be honest with you, I forget it every year. I mean, it's like I have it, but I don't know, I always forget the order. I think it's 3 sine x minus 4 sine cubed x. I think that's what it is. But I forget every year because the cosine one is like 4 cosine cubed x minus 3 cosine x or something, gets flip-flop. But I forget them. But what I do is I go, all right, can I prove this identity? Say I forgot it. This has nothing to do with this. Is it the sine of 3 theta the same as theta plus 2 theta? Isn't that sine of 3 theta? Isn't that kind of like an alpha plus beta now? Huh? So if that's like an alpha plus beta, if this is my alpha and that's my beta, how would I expand that? Sine alpha cosine beta plus cosine alpha sine beta. And do you have an identity that changes double angle cosines to nothing but sines? I do. So I'm going to bring down the sine, and I have a double angle cosine that's 1 minus 2 sine squared theta. Are y'all with me? Now, let me ask you this. Do you have a way to get rid of the 2 theta here? What's sine of 2 theta? 2 sine theta cosine theta? Right? Which now gives me what with these cosines? Cosine squared? Oh my gosh, is there a way to change a cosine squared into a sine? Is there? What's cosine squared the same as? 1 minus sine squared? And if I distribute all this out now, I get sine theta minus 2 sine cubed theta, 2 sine theta minus 2 sine cubed theta, which is 3 sine theta minus 4 sine cubed theta. And I literally will do that every year to remember what it is. And then once I do it, I usually have it stuck in my head for a couple months and then I forget it. But that's a triple angle identity. Well, if that's the triple angle identity, can't I replace sine of 3 theta with that? So, let's take a look. That gives me negative sine of 18 times 3 sine 18 minus 4 sine cubed 18. And then all I have to do now is plug root 5 minus 1 over 4 in for sine of 18 and algebra the crud out of this. Or is there a better way? Like, what if I got a little creative because I'm looking at this right now and going, cubing that? that times that times that, I'm not a big fan. But what if I said, what if I factored one of these sine of 18s out? That would give me negative sine squared of 18, and then just a 3 and a 4 sine squared of 18. That I like a little better, because that would enable me just to square that first, and then plug it in. So if I squared that, how do you square that fraction right there? Square the first, that times 2, square the last, over 16. So I get 6 minus 2 root 5 over 16, which is 3 minus root 5 over 8. So I'm going to take 3 minus root 5 over 8, and I'm going to plug it there. So, and I'm not going to finish this algebra. I'm just going to show you the process. And then I'm going to plug it there, because that's my sine squared. And it's still ugly. I'm not going to lie, that's pretty gross. But if you clean all that up, distribute the 4 in, find a common denominator, FOIL all that out, this kind of ends up looking like a conjugate. The root 5 junk cancels and leaves you with this. Now, am I going to give you that on a test? Probably not, but I could totally give you just this part and see if you could go, all right, can I just do that part right there? Totally have done that in the past. How about number 3? Yeah, and then I want to do number 4. This is technically on a different section of trig that we're going to do later, but it says in a triangle ABC where A is the opposite side A, B is the opposite side B, I'm sorry, A is opposite A, B is opposite B, and C is opposite C. So it doesn't say that it's a right triangle, but it just says something like this. Tell me if this rings a bell. It says if A is 5, B is 7, and sine of A is 3/7, find the sine of B. So you know this, you know this, you know the sine of A, you're looking for the sine of B. Is there anything that you know that you've learned that relates the sine of angles with their sides? You learned these last year. Do you remember actually learned them in Helmer's class too, and maybe even in Tyree's. Do you remember the law of sines and cosines? The law of sines or the law of cosines? What did the law of sines say? Sine of A over A equals sine of B over B equals sine of C over C. Sorry. Sine of C over C. What do you know right here? You know everything you need, don't you? There's your A, there's your B, there's your sine of A, that's the whole thing, and I need to find the sine of B, so I don't even have to solve for B. I literally just plug in 5, 7, 3/7, multiply by the B, and I'm done. This is one that I told you to eliminate from the last test, because we really didn't give it much time. I don't even know if I got through it all the way. No, I didn't. I started doing it, and then I didn't do it. But here we are. So, got to tackle it. This time I could promise you it's going to be on this test. So, the sine of the arctan of 1/2 minus the arc cosine of 4/5. So what does arctan and arc cosine mean again? Inverse. So if I'm inverse trigging a number, that number stands for the what? If I'm inverse trigging a number, that number stands for the ratio of the two sides. And once I inverse tan the ratio of the two sides, it spits out for me a what? An angle. So this inverse tan and this inverse cosine are going to give me angles. So essentially, what kind of problem is this? This is a sine of alpha minus beta. Just hidden. And if you were going to find the sine of alpha minus beta, what identity would you use? Sine of alpha minus beta, what's that identity? Anybody know without looking? So you said sine, cosine, but sine of the alpha, and the alpha is that. So sine of the arctan of 1/2, that's the sine alpha. cosine beta, and the beta is that, so cosine beta inverse cosine of 4/5. Then it's minus here on the sign, then it stays minus. Then cosine alpha, and again the alpha is arctan of 1/2. And then sine of the beta, and the beta is inverse cosine of 4/5. Are y'all seeing that? Now if you really look at it, isn't each one of these the same thing I did in, I think it was problem 1, wasn't it? Where I did the cosine of the arctan? Except I gave you numbers and not variables, which makes it a little easier on you, right? So what did you have to do to find the cosine of an arctan, or a sine of an arctan, or a cosine of an inverse cosine? Seems to me like I need to do what? What do you do to find one of these? Draw a triangle. Or draw a picture, yeah. So I'm going to say, all right, inverse tan. Where would an inverse tan show up? First and fourth, but it's positive, so have to be in the first. So whatever this angle is, I don't know what it is. I'm going to label it right there. And if the tan, inverse tan of 1/2 is, gives me two sides, that's the opposite and the hypotenuse, and the square root of 5, I'm sorry, the opposite and the adjacent, the square root of 5 would be the hypotenuse. And I need to take the sine of that angle. So the sine of that angle would be 1 over root 5. So all of that, I'm done. Now the next one, be careful, you can actually just cancel the inverse cosines there. Because the rule is, as long as either that angle or that value is defined where inverse cosine is defined, it cancels. And it's not an angle this time, it's a value, but it's supposed to be between -1 and 1, you're okay. If it was an inverse kind of inverse cosine of a cosine, then the angle would need to be between 0 and 180 for you to be able to cancel. But it is, it's within those bounds, so I could just take a shortcut and just cancel them. But at some point, I'm going to need to have this picture drawn. So I'm going to go ahead and draw it. Where is inverse cosine defined? 0 to 180, but it's positive. So over here, 4, 5, that's a Pythagorean triple, so put a 3 in it. And if that is my beta right here, what is the cosine of that beta? 4/5. So it worked out, but we could have just canceled. And then now the second part shouldn't be that bad, because again, inverse tangent of a 1/2, that's my alpha. Inverse cosine of a 4/5, that's my beta. So what's the cosine of this alpha? 2 over root 5. And what's the sine of that beta? 3/5. So I end up with 4 over 5 root 5 minus 6 over 5 root 5, which is -2 over 5 root 5. But then, like every good pre-cal student, we rationalize and we get -2 root 5 over 25. Now I can promise you, you will see a problem like this on your test. Promise you. And if we ever go to a math tournament again, you'll see one of those. They show up, it's just too easy a problem to come up with when you're like, man, I need 5 more problems. What could I do? Boom. I mean, it just checks a lot of different aspects of trigonometry. It checks, do you know your inverse rules, where they're located? Do you know the trig functions? Do you know your identity? Can you multiply? Can you rationalize? It just checks way too many things to leave it up. This problem I thought was pretty brutal. Because this one is very similar to the one you just saw, except what's missing? This is the arcsine of 3/5. That's like the alpha part. This is like the beta part. But you're missing the trig function part. Now you might go, well, that's not a big deal. I can just find alpha and beta and call it a day. Well, the problem is, I can't find alpha. I can draw a picture, right? I mean, I can draw a picture of this and go, all right, 3/5. Sweet. Are you any closer to knowing what alpha is? No. So you look at this and you're like, what the heck? I remember when I first saw this, I'm like, I don't know how to do this. And then I came back later and went, wait a minute, look at the answers. The answers there gave me a hint to what I might do. Now, I'm not going to get to completion on these, but look, arc cosine, arc sine, arc cosine, arc cosine. Well, just eyeballing this, there's a whole lot more options for arc cosine. So I thought, well, maybe I could just cosine that. And when I'm done, I can arc cosine it and get out of it. Like, let's just think about it. If there was a cosine on this problem, what would you have done? What would you have done if there was a cosine? Cosine alpha plus cosine beta, which is cosine alpha, cosine beta, minus sine alpha, sine beta, right? And what's your alpha? Arc sine 3/5. So inverse sine 3/5. I can put that in there over here also. And what's your beta? Arc cosine 5/13. I can put that in here. So, cosine of alpha plus beta, I'm leaving the alpha plus betas in here right now, just to make it easier to write, okay? How would I do that? Well, I've already got that set up, right? So what's the cosine of it? 4/5. So all of this ends up being a 4/5. What do you think cosine of inverse cosine of 5/13 is? And I can do that, right? I can cancel this because 5/13 is in between -1 and 1. What do you think sine of inverse sine of 3/5 is? 3/5. And I can do that because the 3/5 is in between -1 and 1. And then for the last one, what am I going to have to do for the beta? Well, I got to draw another picture, but it is positive, so I can label it 5/13. Thankfully, that's another triple, right? 5, 12, 13. And what's the sine of that? 12/13. Now, you get down to here and you go, all right, 20 minus 36 over 65, negative 16 over 65 is that. You with me? But here's the thing. I didn't ask you to put the cosine in there. Did I? So if I didn't ask you to put the cosine in there from the beginning, I got to get rid of it now. How do I get rid of it? Inverse cosine both sides. And I get alpha plus beta equals inverse cosine of negative 16 over 65. C. Now, what if I got positive 16 over 65? And I'm like, crap, that's not an answer. Guess what I probably have to go back and do? Since inverse cosine's not working, I'd have to go back and try the sine. I'd have to try sining both sides. It's a totally different identity, but at least I got my pictures drawn. And I'd have to see if that worked, and if that didn't work, I'd go with E. Or cry to mama, one of the two.
Are you going to take up all the worksheets, or do we just get to turn the book contest today?
I've been taking up everything.
Well, they just were on like the homework side of the sheet, so that's why I just wrote down.
Yeah, sometimes I can't, sometimes there's more writing that I need, so I'll write out an explanation of what I want. But if you have any questions, you can just ask me if you want that. But usually it's like, I would want this, although we're going to do a lot of it. But are you kind of seeing this? Now, if your big question is, which it normally is, are you going to do this to us? No. But I totally could give you one that says cosine out front, just like the problem before, right? Am I going to give you this? No. But this is an old Vestavia question. And it's probably number 25 or 23. I mean, I doubt a ton of people got it, but now that I've seen it, I know to think this way. Oh, I can just throw a cosine on there because I can't do it without a trig function in front. And then I can take it away at the end. Now that I have that strategy in my toolbox, I am equipped, ready for action. 1 minute. Anybody got an idea what they would do here? I'd love to be able to factor it, right? I'll talk about this later. If you look at your assignment sheet, it says we're going to do those today, and we're going to finish up talking about them tomorrow. You may get in here and go, man, I couldn't do a fraction of these. That's okay. Do the best you can with them. The ones you don't understand, take a look at the key and come with questions tomorrow. We'll talk about them tomorrow, and then we're going to start our review tomorrow, and then you guys are off. Or send them to me. I know you're not going to physically be here. Send me a question, and I'll make sure I talk about it, because I can't talk about everything. But your review is probably more likely the level that you're going to look at. And don't forget to omit the ones that I say to omit. All right? Because some of them, like this, right here, this next one, super easy question if you know the identity. You don't know the identities. And if you don't practice the identities, guys, like I'm asking questions that normally people answer immediately, you got to know your identities. Are you with me? Keep practicing those.